This is the fourth part on chapter on matrices. From exercise 10, you're going to do question number 23. Show that if M is this matrix, then M squared minus 6M plus 9I is equal to 0. You have to show that M squared minus 6M plus 9I is equal to 0. Showing something or proving something means you will start from one side and try to get the other side. Okay. Where it also says where I, you can see M is involved. M you already know. This involves M, this involves M, and this involves I. Here it says where I is a unit matrix of order 2. I is a unit matrix, identity matrix or unit matrix of order 2 means it's a 2 by 2 matrix. So you have to show that M squared minus 6M plus 9I is equal to 0. So let's start with the left hand side. The left hand side is M squared minus 6M plus 9I. Only that much I have written. That's the left hand side. Okay. Now, let's substitute. You know M is this. Okay. So M squared is M into M. This is M into another M. Minus 6 has to be multiplied with matrix M. Plus 9 has to be multiplied with I. I is an identity matrix. I told you before also about identity matrix, where the diagonal elements are 1s, the rest are all zeros. So 1, 0, 0, 1 is an identity matrix. Okay. So we put all these values now to simplify. This matrix has to be multiplied with this. So first row with first column, which means 4 into 4, that is here, plus 1 into minus 1, plus 1 into minus 1. This is done. Next, first row with second column, that one, which means 4 with 1 and 1 with 2. 4 into 1, that one, plus 1 into 2. Then, second row with first column, that means minus 1 with 4 and 2 with minus 1. Minus 1 into 4, plus 2 into minus 1. And lastly, second row with second column, that is minus 1 with 1 and 2 with 2. Then minus, multiply the 6 with everything. 6 4 is 24. 6 into 1 is 6. 6 into minus 1 is minus 6. 6 into 2 is 12. Plus, multiply the 9 with everything. 9 into 1 is 9. 9 into 0 is 0. 9 into 0 is 0. 9 into 1 is 9. Simplify this first. That's 4 into 4, 16. And this is minus 1. 16 minus 1 is 15. 4 into 1 is 4. Plus 1 into 2 is 2. 4 plus 2, that gives you 6. Then 4 into minus 1 is minus 4. And this is minus 2. Minus 4 minus 2 is minus 6. And last one, minus 1 and plus 4. That's 3. Then this I have written as it is. This I have written as it is. Now this matrix minus this matrix plus this matrix. This subtraction and addition. So use each element separately. So 15 minus 24 is minus 9. Minus 9 plus 9 is 0. Then 6 minus 6 is 0. Plus 0 is 0. Minus 6 plus 6 is 0. Plus 0 is 0, and 3 minus 12 is minus 9, plus 9 is also 0. This is called a zero matrix where all elements are 0. Check and see what your right hand side was. Your right hand side should be 0, which means a zero matrix. 0 here means a zero matrix. So check and see whether you got a zero matrix. It is a zero matrix, therefore the left hand side has become the right hand side. So you prove this. Next, question number 29. Let A is the matrix, these are the elements, B is the second matrix, and C is the third matrix. Find A squared minus A plus BC. Here you are not going to prove. Here you are going to find a value. Find A squared minus A plus BC. So substitute the values. A squared means A into A. This is A, this is also A. A into A, then minus A, this is matrix A, plus B into C. B I have written here into this is C. Now to simplify this, let's go with this multiplication first. First row with first column, which means 4 into 4, that is here, plus minus 2 with 6, plus minus 2 with 6. That's done. Next, first row with second column, that one. 4 into minus 2, plus minus 2 with minus 3. That's also done. Next, second row with first column, which means 6 into 4, plus minus 3 with 6, minus 3 with 6. Next, second row with second column, that means 6 into minus 2 and minus 3 with minus 3. This into this is multiplied here. Then minus this as it is I have written. I have not changed anything. Nothing to do there. Then plus we have to multiply now. We are going to multiply first row with first column. That's 0 into minus 2 and 2 with 1. And then first row with second column, that one. 0 with 3 plus 2 into minus 1. 2 into minus 1. Next, multiply second row with first column. 1 into minus 2. 1 into minus 2. And minus 1 with 1. Minus 1 with 1. And then lastly, second row with second column. 1 into 3 plus minus 1 into minus 1. Multiplication is done. Now is the simplification. 4 into 4 is 16. 6 into minus 2 is minus 12. 4 into minus 2 is minus 8. And minus 2 with minus 3 is 6. 6 into 4 is 24. Plus 6 into minus 3 is minus 18. Then this is minus 12 and this is plus 9. This I have written as it is. Plus, simplify this. This is 0 plus this is 2. This is 0 and this is minus 2. This is minus 2, minus 1. And 3 and plus 1. Let's add them. 16 minus 12 is 4. Minus 8 plus 6 is minus 2. 24 minus 18 is 6. And minus 12 plus 9 is minus 3. This is still the same. Plus, this is 2. This is minus 2. This is minus 3. This is 4. Now to subtract and add these matrices, let's do the subtraction and addition. 4 minus 4 gives you 0. 0 plus 2 gives you 2. Minus 2 plus 2 is 0. Plus minus 2 is minus 2. 6 minus 6 is 0. Plus minus 3 is minus 3. Minus 3 plus 3 is 0. Plus 4 is 4. So that is your result of a squared minus a plus b squared gives you this value. Next question. Question number 53. Evaluate 4 sine 30 degrees, 2 cos 60 degrees, sine 90 degrees, 2 cos 0 degrees multiplied with a second matrix which is 4, 5, 5, 4. These have trigonometric ratios. Okay. And do not multiply this with this directly. You will get too many trigonometric ratios. So what you will do is substitute these, that is sine 30's value, cos 60's value, sine 90's value and cos 0's value first. Simplify them and then lastly you can multiply. So 4 into sine 30 is half. Then 2 into cos 60 is also half. Sine 90's value is 1. And 2 into cos 0's value is also 1. That's done. You put the values into the second matrix. This is the second matrix. Simplify this further. Okay. You can cancel. 2 and 4 goes twice. 2 and 2 gets cancelled. So 2 is what is left. Here 1 is left. This is 1. 2 into 1, that's 2. Multiplied with 4, 5, 5, 4. 4, 5, 5, 4. Now comes the normal multiplication. Multiply these two matrices. So, we multiply first row with first column. That means 2 into 4. 2 into 4 is 8. Plus 1 into 5. Plus 1 into 5 is 5. Next, first row with second column, that one. 2 into 5, which is 10, plus 1 into 4, that's 4. Next, second row with first column, that means 1 into 4, which is 4, plus 2 into 5, which is 10. And lastly, second row with second column, that is 1 into 5, which is 5, plus 2 into 4, which is 8. Simplify this. Now add them. So you get 8 plus 5, which is 13, 10 plus 4, which is 14, and 4 plus 10, which is 14, and 5 plus 8, which is 13. So this is your result. Once more, I am telling you something about this. Never multiply this matrix and this matrix straight away, because these have trigonometric ratios. If you multiply, there will be more of these trigonometric ratios repeating. So it's better you substitute these values first and then simplify them, and then lastly you can do the multiplication. Your homework is exercise 10, question numbers 24, 45, 57, 61 and 62.